Okay. Couple items before we get started. A, we want to go fairly fast, just like for the actual final block. You got 90 minutes for each half, so 90 minutes, 20 questions, average about 4.5 apiece. So this is also why over the course of the semester, as we've been doing daily quiz, you know, if that's taking you 10 minutes, that's probably too much time. Okay. When we go through all of this, I'm going to try to turbo it out. Hopefully you have all done the review beforehand. As we go through each one, I'm also going to try to talk about these are the things that kids usually get wrong. As I had said before, I know because of the last year, a good chunk of you have not taken the traditional Algebra 2 final, so you don't know what the real multiple choice test looks like. Multiple choice test looks like, here's options that you would have gotten if you did it wrong. That's how the ACT is. So just try to have it model a reasonable, accurate, valid assessment. Through 20 today, that'll get us into Chapter 4. Tomorrow, back half, Chapters 4, 6, 7, and 10. I double-checked through it. There is a single question that we did not cover. So we're just going to cross that one off, and it's out of 117 points instead of out of 120. I think it's number 30-something. It's the find inverse of a matrix. And it's actually super, super easy, but we just didn't get there. Yeah? So, we'll get rolling. Also, I'll say it now. I'll probably say it again tomorrow, just because I want you to come in on final day ready to go as much time as possible. Because there's always, most kids finish about an hour or so. There's always, in a group this size, there's always about 2-3 kids who are just furious scrambling at the end. Okay? So I want to give you as much time as possible during the actual final blocks. So when you come in on those final days, so far, I don't think anyone has rescheduled anything with me. As to, I don't want to take this, my maroon day really sucks. I really don't want to come in here and take my final that day. Can I do the first half of it on my open block on Thursday instead? Okay. If that's the case, you need to tell me before Wednesday. When you come in on final day, phones will go up front. No phone, no final. Bags will all go up front. Nothing near you. All you should have in front of you on final day is a calculator and a pencil. That's it. Also, I've got enough forms of the test that in a class of, well, no, Abe took his early. So in a class of 20, there's only going to be one other person in the room who has the same final as you. There is no point looking around, because I also organize them so that your final is probably his final on the opposite side of the room. Okay? Phones and bags will be up here. Remove temptation. At the end of the class, you are where you are. Turn it in. Every problem, multiple choice, 5 answers. One of them's correct. 4 of them are what you would have gotten if you put a parenthesis instead of a bracket, if you missed a negative, if you squared like a freshman, if you X, Y, and Z, the most common errors. Every one of them is worth 3 points. One is reasonable work related to the problem. The other is correct answer, or the other 2 are the correct answer. So if you know your math ratios, that means you can do the entire final having gotten half of it wrong, but having shown work. Only half right, you still got a 67% on the final. It's very difficult to fail it. It's very difficult to get an A. All right? With one question crossed out, I think it's like 3 wrong is the threshold.
So, you said show reasonable work. Well, like number 1, for example, there really isn't.
Okay, that's part of what we're going to go through, is what constitutes reasonable work. And I mean reasonable work doesn't have to be crazy, it just has to be, well, reasonable. Domain. If you just do this and say A can't be -5, if you just look at those two and say there's a horizontal asymptote at 0, there you go. You just sketched out, this is why I got this information. Because I know where the vertical and horizontal asymptotes are of this function. That's it. That's your reasonable work. Or maybe you just have a sketch. If you just have the sketch, that says, I put this in my calculator and I recognize that it doesn't exist at these two spots on X and Y axes. Okay, that's reasonable. Right? You don't have to write a dissertation for every one of them. I just need something that says I didn't just guess. Okay? Also, maybe a note to yourself, that also means don't just guess. Don't just circle one and move on. Even if it's something you did all in your calculator, maybe you just did it in your head, cool. But do you have something to back it up? If you don't, you just left money on the table. Okay? So anyway, if x cannot equal -5, then right away, I'm getting rid of things that are talking about +5. X cannot equal -5. What else has to be thrown out? Purely based on domain. Brackets mean it equals this. Parentheses mean can't touch this. So C and E, those are my options. Then it comes down to, do you remember how range works for these? Range is what Y values aren't allowed to the party. And I see that there's a horizontal asymptote at 0, so I know that 0 is also not allowed. Okay? At the beginning, Andrew had a really good question, said, as we're doing these, like, how do we know which formulas are going to be up on the board? If we're doing any of this stuff, and there is a formula that is not conceptual that I think you should just know, like that formula cheat sheet for any other standardized test, I'll write it up there as we go, and then on final day, I'll have it just all like pretty written in a corner so everyone can refer to it, okay? Zeros and y-intercepts of a function. To find zeros, then we set my function equal to 0 and solve, right? Put 0 in for y, you get x-intercepts. So if I put 0 in there, I'll add 1, square both sides, subtract. Cool. So I got -2. Did I square root? Oh, sneaky, sneaky. So I've got an x-intercept at -2. Already? Probably that one. Right? Probably. Oh, wait a second. There's other things up here that got a -2. Maybe I should go find the other one too. If I want to find a y-intercept, I put a 0 in for x. And get, the y-intercept is the square root of 3 minus 1. Notice what A has. Notice what E has. Take a wild guess what the decimal approximation of square root of 3 is. Told you on day one when you came in here, we're big kids. We're going simplified fractions, simplified radicals, simplified terms of pi, I, and e. If you ever see a decimal, be very wary of that answer. Okay? So it is this because the entire expression, square root of 3 minus 1, is my actual value of the y-intercept. But being able to find x and y intercepts, zeros and y intercepts of a function, that's something that goes all the way back to algebra 1. Put a 0 in for one to find the other. Continuity, it doesn't say to do it with the continuity test. It just says tell me the continuity. There are four types of continuity. One is it's actually continuous. The other is removable discontinuity. That's when I have x minus c over x minus c, I don't know, something like that. Removable discontinuity comes when I can actually remove a factor. What feature does it result in? A hole. And important thing to remember about holes and our calculator screen, you don't see it. You might type a function that has a removable point of discontinuity on it into your calculator, and all you see is a line. All you see is a rational function, and at that point it looks like it's fine. You have to know how to find them first. What else do we have? We have infinite discontinuity. Infinite discontinuity happens at vertical asymptotes. Okay, vertical asymptotes, because my behavior as I approach that point is to either plus or minus infinity. Jump discontinuity only happens when you have two rules or more, I suppose. When you have multiple rules and they state the restriction on the domain of where you're going to do those rules, a piecewise function. Now, when I look at this, you might be tempted to just circle that bracket and say it's a piecewise function and then go say jump discontinuity. Look at where they're testing. Determine the continuity at x equals 1. If I had said anywhere but x equals 1, it's continuous. The only possible place that I could have discontinuity on this is if it has denominators with x's to get removable or infinite, or at the break between rules on a piecewise function. Those are the culprits. Those are the places that I need to look. If I don't look at those spots, well, then something could go awry. Also, if this had been like 1 over negative x, I need to look at not just where the rule is, but I also need to look where. Like x equals 1 is the spot where it switches from rule to rule. I need to test that value. What else should I test because of this? Who's going to break math? 0. So if this said at x equals 1, okay, I'm testing the boundary between the two rules. If it says x equals 0, I would be testing one of the asymptotes of part of the function. I have to see if it's, well, it depends on the two different aspects of the graph, because if I remember right, it's been a long time since I've done this. If I say 2x minus 3, I start right here, do this. But I only care about it when x is less than 1. So here. If x is greater than or equal to 1, I care about that line, which says, that's that line normally. I only care about it from 1 onward, which, coinky-dink, if I were to actually graph these, I would see that one rule begins where the other ends. And it happens to be exactly where I'm testing. The continuity test says when x is 1, they both were at -1. You test the value and see, does it exist? You test the limit of the function as x gets really close to that value and say, does it exist? Finally, do those two things equal each other? So the function of 1, I'm going to put in the second rule because it says or equal to. I get a -1. Cool, checks out. Passes the first part of the test. The limit as I approach 1. And you notice on this rule, as I approach 1, and on this rule, as I approach 1, on the x-axis, in both cases, the y's were approaching -1. So the limit was -1. -1 equals -1. It passed the continuity test. So when I say reasonable amount of work, or reasonable work for your answer, if all I saw was that sketch, showing that they meet at the same point, one ends where the other begins, I'd consider that sufficient. Turns out it's continuous because it passes all 3 parts of the test. But there's a lot of kids who are just going to see this and go for C. They're going to try to shortcut it, do the whole thing. End behavior. End behavior means as I go all the way to plus or minus infinity, where's my graph headed? And it can be so simple as find function of spam 9s. Find function of spam -9s. Remember, if I do those in my calculator, just spam really big number in either direction, it's going to give you the approximation of where this thing is headed. Now, if I do, on this particular one, y is x, no, over, was it x plus 7? Standard. Oh yeah, we were doing stuff in algebra too. Plots off. What? Oh. There we go. Okay, this thing seems to head off in both directions. If I go to my table settings, remember I can switch those over to an ask feature, so I can input whatever I want. And I'll say, as I go all the way out to positive infinity, where's this thing headed? And the more values you spam in here, eventually it's going to, it depends. It might quit and just round it off. Other times you might see scientific notation. We ran into a bunch of times, remember if it's like -1.3296 e negative, what does that say? Pretty close to 0, right? That's that number, but move the decimal 72 spaces that way and fill it in with zeros. Really, really small. So sometimes you're going to have to be smarter than the calculator. So I see in either direction my limit as I approach both positive and negative infinity is 1. Pay attention to the notations too. That one should immediately be tossed out. End behavior. The end of the function's domain is not at -7. Watch out for things like that. Watch out for the signs on them. Maybe they're swapped from what you expect them to be. All right, that was end behavior. Okay. So that's parent function. We're going to go move stuff with it. If you don't remember how this works, f of x minus a, h, and k, technically, although we didn't see it very often, there's also a b right there. What does a do? Vertical stretch and compression, also just called a vertical dilation, and reflection. Note that those are two different transformations. A reflection is separate of a dilation. They occur in the same spot, though, which is what can get confusing. H. What's it do? Horizontal translation, left and right, and because it's grouped in with the x, bass-backwards land. K. Vertical translation, up and down. So if I say 3 units down, I'm going to tack a -3 on the end of this. Reflected, horizontally. Grouped in with the x in the b spot. So it should be g of x is going to be the square root of a -x minus 3. Look at where that negative and that positive kept shifting around, where the 3 shifted around. It's just looking for which one of them is the right one. Do you know which spot this goes in? If you know that, you know how many kids will put the vertical translation in the horizontal spot and the horizontal spot in the vertical spot? Dude, it happens all the time. But if you recognize that, as soon as you see the word 3 units down, okay, process of elimination, cross them out. That can also be a reasonable work. As soon as you see 3 units down, cross those 2 out. Reflected horizontally. Maybe I do this, and I say, that one's got to be out. Like just coding your lines like that. So underline this part, cross those 2 out. Squiggle line this one, squiggle line that one out. I'd call that reasonable work because you're showing me your process of elimination. You're saying this thing means those ones can't be it. I'm okay with that. But you got to have something. Okay, f divided by g. I've got x minus 7 over x squared minus 14x plus 49. Literally f divided by g. And that's not one of my options. Why not? Okay. X minus 7 over x minus 7, x plus 7. No, that's x minus 7. Okay. So if I cancel those out, I got 1 over x minus 7. Cool. So you notice how this is if I had screwed up which one's which, done g over f by accident. That's out. That's out. Those all say 1 over x minus 7. The difference between them all is the domains on them. Who's not allowed to the party? 7. Do you see how if you had done exactly what I had just said and accidentally thought that was x plus 7, x minus 7? You see how you would have gotten instead doesn't equal maybe a -7 with it? Or maybe you just didn't recognize that that was even a problem. So you said all real numbers. Okay. Remember our commandments of domain. Thou shalt not. Divide by 0, even root of negatives, log of non-positives, and then arc sine or arc cosine of value whose absolute value is greater than 1. Okay. Compositions. We learned this back in Algebra 2. What goes into what? G goes into F. F of G is square root of thing minus 2. G is 4x minus 2, which is the square root of 4x minus 4, which is option E, which is wrong. Why? You know how many kids are going to think that you can do this? Don't do that. Don't do that. Why not? That's a difference. I can only take out products, factors. I need to turn that into the square root of 4 by x minus 1. Now it's a product of two things. Now I can take it out. 2 by the square root of x minus 1. How many times over the semester have I said, don't do freshman math? That's freshman math.
What you did, the 2, and then if you x minus 4, that's not even
Okay. There's a lot of kids who would goof it.
oh, no, but I would say freshman math.
Yeah. All right, inverse of a function. How do I find an inverse? Okay. X's become y's, y's become x's. F of x gets me y, so if I swap x's and y's now, we'll have y over y minus 5 is x. How the crap do I deal with that? Okay. Cross multiply. Now what?
This one, we subtracted x minus, x y.
There's a lot of kids who are going to do something really, really dumb right now, like divide by y and just call it a y and go for it. Don't do that. No. We learned this back in Algebra 2, actually Algebra 1. That's, if I have y is xy minus 5, just like if that was 5x equals 3x plus 2, you would get the x stuff on one side, right? If I want y by itself, get the y stuff on one side. There's an x? Oh. Yeah. Again, common error I see. Someone's going to come along and try to do this. Why is that wrong? You have to divide them all by x, and now you got an x on denominator again. You're just going to be a Yorkie chasing your tail, going round and round and round and round and round. Unless you recognize I can factor that y out, divide by 1 minus x. But that's not any of my options. Okay. Now it also depends on which way you put stuff when you were getting y by itself. So I see not that one. You've got a negative, not that one. You're not even close. Uh-oh. Well, since 1 minus x wasn't one of my denominators in any of my answers, I have to make it look like one of my answers somehow. Okay. So who's not allowed to the party? Is it just 1 or is it 1 and 5? Remember that in the original, we had x cannot equal 5 for a domain, range y cannot equal 1. Remember, degrees are the same, leading coefficients, vertical and horizontal asymptotes. What happens when you make an inverse? Domain and range swap. So the range of this one becomes the domain of that one. No. No. My answer key's wrong. Oh, answer key's wrong.
Yeah, you flip the domain and range.
You swap domain and range.
I think the entity, I think they just found the restrictions, like just not singularly. But I think
Oh.
the restrictions for the whole.
But it says any restrictions. Oh, wait, yeah.
on the domain. They did it.
Find the inverse of the function, including any restrictions on the domain. Okay, so in that case, we'll just be clear about restrictions to the domain of the inverse that you found. Okay? That was probably a issue in wording that in a previous class we had to fix. And honestly, I haven't changed the review key on this for 6 years. I've changed the finals, but not the review. So, oops. I've got 16 forms of the final. So I just rotate, spin them around between kids, and I actually use a random number generator to determine where I'm going to start printing too. So each year, the order and who gets what actually changes from class to class because I do it randomly. It's a lot of work to set up, but once you have it set up, it makes things so much easier. Yes.
There's no point in trying to memorize. You're better off trying to memorize.
And I use a random number generator for how I place the answers. So if there's 5 answers for number 9, I use a random number generator, say random integer 1 through 5, that's where I put the answer. Random integer 1 through 5, that's where I put the answer.
So 2 kids could have like the same problem, but their answers are different.
Yes.
Oh.
And because it's done with a random number generator, that means human beings are horrible random number generators. There are streaks in random numbers. It is possible that one of you might get a test where there are 6 or 8 problems in a row that are all B. I do this to discourage kids from even trying to get squirrely on me. Like, y'all, I did the work. Do it for real. Yes. So, with that said, find all the zeros of the function. I'll tell you right now, this thing is factorable, as will be the one on your final. If I recognize quadratic form, and turn that into x squared plus 4, x squared plus 3. Take out a negative 4x here, leaving a x squared plus 4. You see how they both have an x squared plus 4 in common. It's called factoring by grouping. You first learned it back in Algebra 2. If I take that x squared plus 4 out, I'm left with x squared minus 4x plus 3, which is x minus 3, x minus 1. And if you remember difference of squares, because that one says plus 4, it's x plus 2i, x minus 2i. Whole thing is done by factoring if you want. If that is not your jam, the alternative to it was I start with synthetic division. Say 1, negative 4, 7, negative 16, 12. And I start using values. Now I have the entirety of all the numbers in the world to choose from. I could use Descartes' theorem to determine pluses and minuses. I could use rational root theorem to bring it down to which are my possible rational roots, all the factors of 12 over all the factors of 1. We can, there's ways to narrow it down, but how am I going to know if you did those ways or if you just gazed into your crystal ball and said, you know what, I'm going to try a 1 first. 1 by 1 is 1, subtract them. 1 by 1 is, or negative 3 is negative 3, add those two together. 1 by 4 is 4, add those two together. 1 by negative 12 is negative 12. Yay, it cancels out. I'm so good at this guessing game, I should try it again. I feel really good about a 3. And because I took a quartic and I reduced it down 2 degrees, I know that this is now x squared plus 4 equal to 0, which I can solve by square roots as well.
So I was doing one of these that had imaginary. In the book, they ended up doing, they put in y and they use it in the
You can. You don't have to. You can do synthetic division with imaginary numbers, with complex zeros. It just gets really gross. I would rather gaze into my crystal ball, do synthetic division until I hit an irreducible quadratic, use quadratic formula, complete the square, or solve by square roots on the irreducible quadratic. I think that's the method that most kids preferred. I'm showing you you can do this by factoring or that method. But in either case, you know, if you plug this into a calculator, you're going to have a 0 here and here, and that's all you're going to see. Admiral Akbar says it's a trap. No. 1, you said it wrong. 2, probably racist, and I'm not surprised. 3, Admiral Akbar is a fictional character. So, if you plug this into your calculator, you're only going to see 1 and 3. That's it. You aren't going to get the imaginary roots that go with it. So please, 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 please remember to take it all the way. It is 1, 3, plus or minus 2i. Also, you got to have work to back it up. If you just guess, I mean, if you guess correctly, hey, 1 out of 5, 20%? Okay, you deserve getting it correct. Cool, great. You're still getting 1 off because you don't have the work to back it up. There we go. Write a function with these zeros. If I know a 0, I know x minus that 0 is one of my linear factors. And if 1 minus 2i is one of my zeros, what else is? 1 plus 2i, its conjugate. Now, the question is, do you really want to multiply out all of it? Do you want to multiply all of it out? Are you going to remember the cheater? I ain't writing it on that board. Very close. Okay, but is it a squared plus b squared or a squared minus b squared? Okay, if I have an I in it, then at the very end of the problem, your I squared will switch up the sign, meaning a squared plus b squared. If you do not, then at the very, very end of the problem, you will have a minus b squared, and that's if it's just a radical with no I. So I can distribute all this out, but at the end of it, I'm going to have x squared minus 2a. What is a? Plus a squared plus b squared. Remember that b is the coefficient of I. Don't put an I in with it. That's already taken care of in the formula. But you ain't done yet. You have to distribute all the way through. Get x to the fourth minus 2x to the third, 5x squared plus 5x to the third minus 10x squared plus 25x, 6x squared minus 12x plus 30. Getting x to the fourth plus 3x to the third plus x squared plus 13x plus 30. Along the way, incorrect answers. Incorrect answers are done by screwing up those signs. Incorrect answers are done by missing the sign here. Incorrect answers are done by including the I in the formula. All kinds of things. Okay. Write your work out. Okay. A third of the test is just, do you have reasonable work? Can I look at the work you showed and say, yeah, they kind of know what's going on? That's all I want. All right, asymptotes of the function. If you remember, is numerator x over denominator of x, which can be written as ax to the n, blah, 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 a constant, bx to the m, blah, 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 plus a constant. If this is what we start with, we're going to have zeros of the denominator get me vertical asymptotes. Zeros of the numerator get me x-intercepts. Because if I were to put in a 0 here, cross multiply, I would get this equals 0. That's how I get my x-intercepts. Put in 0 for y. My horizontal asymptotes, I should say oblique or horizontal. If, remember there were rules here, if n is less than m, what's my asymptote? If the degree of the numerator is less than the denominator. If it's less than, your x-axis is. If they're equal, that's when it's the leading coefficients. If it's 1 greater, which is all we saw, then you have to divide to get an oblique asymptote. We did not see anything that had a quadratic or higher asymptote. You can have quadratic or cubic or quintic asymptotes, and they look really funky, but you can. Oh, and then y-intercept, if I put in the function of 0, I'm going to get c over d for a y-intercept. Okay? So, in this one, I got 2x, x plus 7, over, careful, careful, x plus 3x plus 9, 6. It's a hell of a weekend. It's also important to factor those out, not just to find your asymptotes, but what would have happened if that was that as a denominator?
Then you would have
X plus 7s would have canceled out, resulting in a what? A whole. The whole is not an asymptote. Number 11 on yours is just going to be find asymptotes of a function, and it's going to be some rational function. You might have to divide to get an oblique one. You might end up with a whole that you have to remember a whole is not actually an asymptote. It's just going to be some rational function. So in this case, I see vertical asymptotes at x is -3, x is -6. These two being separated, it's also a little bit of a tricky, that is 2x squared plus 14x. So that means my degrees of numerator and denominator are the same. If they're the same, then that means 2 over 1 is my horizontal asymptote. Okay. Yeah, you'll still have 2 over 1 leading exponents, or leading coefficients. Notice that 2 of them don't even have the horizontal asymptote on there. That's probably what you're going to see if you just dump it in the calculator. Also worth noting, a bunch of these types of problems, when you look at them on a calculator screen, they might have asymptotes like this. In fact, I'm pretty sure that your quiz this semester looked like this. Where that's all it looked like. And if you did not understand that there was still an asymptote there, and that happened, I know that happened on at least one of our quizzes. And there was a bunch of us who just believed the calculator and thought there was a hole there. Calculators don't show holes. Sometimes, oh, you got to zoom way in. I think you got to get a window that's like a 10,000th of a unit to finally see it. It's ridiculous. If your graph curls too close to an asymptote that your calculator is supposed to not show, it's going to look like it just disappears. Now, this is also a difference in technology. If you're running a TI-84, it'll look like that, the purple stuff. If you're running a TI-83, they actually put a black vertical bar where the vertical asymptote is. That was something that they fixed going from 83 to 84, is they used to actually show that asymptote. And kids would get confused thinking the asymptote is part of the graph. Okay. What I would strongly recommend here factor where you can. I'll turn this into a -1 over. Don't ever leave the sign out front, just put it up top. Boy, oh boy, do I got a lot of kids who will just pretend that 1 minus d is d minus 1. They are not. I got kids who will then come over here and take this times d minus 1 or 1 minus d and think that the whole thing is now cool. Oh, that's a -1, yeah. Why is this right now still wrong? Exactly. When this happens, what I'm going to recommend everyone does, yeah, I can put that negative up there, but then I need to take this whole thing times -1 over -1 to turn that into a +1 over d minus 1. Okay. You just, 1 minus d is not d minus 1. Watch your factors. Now, if I multiply by that same denominator all the way across the way, I missed one up here. Now I'll get d minus 1 is 1 plus d plus 4. Well, wait a second. If I cross out the d's, I got -1 is 5, and that's not true. But if you thought 1 minus d was d minus 1 and just went for it, you would have gotten at least one of those. Okay, you need to get common denominators. You first saw this. In fact, this exact problem right here, I took it out of the Algebra 1 textbook. That exact problem. You've been doing them for a long time. Or should have. Solving inequalities. When I solve a nonlinear inequality, I'm looking for two things. Asymptotes and x-intercepts. Because if I want to know where this is less than or equal to 0, well, let's say I factor out an x squared. If I were to just look at the sketch of this graph, which constitutes reasonable work, by the way, it's going to have a 0 at 0 and a 0 at -5. You remember end behavior and how all that works? Where does this graph start? The limit as it approaches negative infinity is where? Leading term test. Negative infinity. I have a positive odd function. By its definition, it's going to start down here and end up here. Because this 0 happened once, it's going to look like a line there to the first degree. Because this one happened twice, it's going to look like a parabola there. So if it starts down here, I know it's going to come up through this to wherever, come down, and because it acts like a parabola here, it's going to bounce off to head off to infinity. I could just look at the graph too on my screen, but the behavior of zeros and the leading term test can give me a quick sketch. And if I've got that quick sketch, and I know this is at -5, 0, and this is at 0, 0, and I'm asking where this thing is less than or equal to 0, well, here it's positive, and here it's negative. So I know from negative infinity to -5, you notice an awful lot of 0s and 5s and infinities and 5s, bracket or parenthesis. More ink here, more ink there. If this is or equal to, I need a bracket.
If you didn't decide between parenthesis bracket on this one, actually would have it down.
Because if you notice, it hits the x-axis here. It is equal to 0 here, which means I need a union with that point, and only that point. I don't want to put parentheses, because that says not touching 0 to not touching 0. That's literally nothing. I don't want to go out to infinity. It's just at a single point. It's only going to be at 0. Notice it's an inequality. If you did not catch that it was an inequality, option A might look pretty solid, because I just look at my graph on the screen, I'd see that it hits the x-axis at -5 and 0, and I just roll with it. A lot of the answers are also incorrect answers, are also differentiating which kids just rely on the calculator for everything. Solve, just like the last one. I need to find vertical asymptotes, oblique asymptotes, and x-intercepts. So I know I have an x-intercept at -1. That's just a negative, there you go. To find my vertical asymptotes, thankfully this is factorable. Factors of 24 that add up to 11, 3 and 8, put a 3 there, take a 3 out, something thirds. So I know I've got a 3 and a 2. And then 2 and a 1. Yeah, 2 and a 1, right? Right? All right, fine, I'll factor it for real because I can't think right now. Factors of 24 that add up to 11x are 8x and 3. Wow. Brain fart. Okay, and we're going to have vertical asymptotes at negative 4/3 and negative 1/2. If I were to look at this on a screen, U means at negative 4/3 and negative 1/2, we're going to have asymptotes. And at negative 1, so right in between, we got an x-intercept. I'm also going to have a horizontal asymptote because degree on the numerator is less than denominator there, which means this thing is going to skirt down through that asymptote. Remember, that's like opening the shield at sector A32. Like, it's that one area, that one tiny area where you are letting it through because there's a convergence between x-intercepts and asymptotes. What you're looking for is maybe you don't know whether it's above or below in any given region. So you test on a number line and you say at negative 4/3, at negative 1, and at negative 1/2, test a number in between each of them. Test a number in each area. Is it positive or negative in each of those spots? Or if you know what the graph looks like, you determine. On the back half, is it positive or negative? Positive or negative? Because it looks like that. So you can see that from the screen or not. At the very least, what I would expect from this is a sketch in the number line to show your work. But if it's greater than or equal to 0, the only place that happens is right here and here. So I need to say from negative 4/3, which it cannot touch, to negative 1, which it does touch, union from negative 1/2, which it does not touch, to infinity. Which is none of them. Oh, that's right. This is one that got it. This key should have it scribbled out. The key should have that scribbled. Or no, not that one. This one. Right? None of them are right. No, none of them are right. But it would need double. That's what I'm saying. I guarantee if I go find my old book, which is still hiding in a shed at home, it's got that scribbled on there. I said I did the review once and then just never looked at it again. The final is solid. $4,000 investment after 12 years, place in an account, offers 7% interest compounded continuously. That one we can write.
It's on the online review.
Remember those two? The bottom one is when it's compounded a particular number of times. When it says compounded quarterly or monthly or whatever. N is the number of times it's compounded. So if I hear the word continuously, I'm using the top one. If I don't hear the word continuously, then there'll be something else in there that says how many times it's compounded. Yes.
Biannually is every 6 months. Yeah, it is 6 months. Or is it every other?
There's not two N's in annually, is there?
Yeah, there is.
It just looks wrong now. My ability to spell flatlined in 2nd grade. If semi-annually, semi means half. Semi-annually is it happens every half a year, so twice a year. Biannually means it happens every 2 years, so it would be half per year. Now what really sucks is I've seen people argue about this. And that. Because biannually is synonymous with semi-annually. The English language is just atrocious. It really is. But anyway, when you plug these into, I mean, I've seen people argue about it. I don't know who's right. I'm not an English guy. Please say amount in terms of time is principal times e to the 0.07 by 12. Please show that. Because if you screw up the actual button pushing, at least you have it written down. Well, even if you just put A equals, that's okay. So, how many times it is compounded per year? Yes. Yes. So, poke all the things. I think I got some of the other ones by, what was it? Just multiplying all of it together. I think I used the regular formula without E. Probably did one with just a 7 there and just a 0.7 there instead of a 0.07. I'm betting those are some of the goofs. 16. Probably. Because not knowing how to turn a decimal into a percent and vice versa. Yeah. Condense the expression. This is from Algebra 2. Log base 3 of. I have power property that says that is now x to the third. I have the sum property that says it can be written as a product. And I have the quotient property that says when I subtract a log of the same base, I can write it as a quotient. Well, none of those are up there. What if I wrote it as a radical? Is that one of my options? Yeah, it is. It's wrong. Why? No radicals downstairs. It's like the first boy-girl party. No radicals downstairs. They're going to give the girls bad ideas. You bring the radical upstairs where you keep an eye on them. Okay. I need to, that's 5x cubed root of x over x. But now that can be reduced. So it's log base 3 of 5x squared square root of x. And that is also not up there. What is going on? Could I have right here just taken 3 minus a half? Okay. Which means it's not just about do you understand logs, but there's hidden practice in here with exponents. Okay, solve. 4 and 8 can both be written in the same base. That's 2 squared to the x plus 3 power. That's 2 cubed to the x minus 5 power. And we have our exponent, what is it? Exponent proportionality theorem, I think it's called. Says if I got 2 to a thing equals 2 to a thing, then thing equals thing. Technically, what you're doing is taking log base 2 of both sides, which is 1, and then these are coming down as coefficients. But common sense also says that thing has to equal thing. And then subtract, add, kaboom. But number 18, when they cannot be written in the same base, you're just going to have to roll with it and use logs as expressions. That's the log of 2 to the 3x minus 1 is the log of 5 to the x plus 4. Because these come out front, distribute, and right now, even though it's big and ugly, it's no different in terms of solving as if I had 3x minus 2 is 5x plus 4. ln or log base pi for all I care. At the end of the problem, because you use the log of the same base throughout it, you should get the same answer, yes. And if I remember right, our book solution manual really liked using ln instead. I'm going to subtract this one over, add that one over. And then I'll have to divide by all that junk. Now, if you wanted to keep going, you can. Five to 625 to 1250. I mean, if you really wanted to keep going and use your properties to combine like terms, you can. But if you jam either one of those into your calculator, you will get whichever one it was. Okay? But you got to have the work behind it to start. Whoa, what are you doing there, Haas? Almost there. Yeah, that's about right. Yup. Take a look at the answers before I even start. Who gets tossed out? Okay. Reading the problem explains the problem. In radians. Which represents a positive and negative angle coterminal with this. Now, yes, I would add 360 or subtract 360 from this, getting positive 30 and negative 690. But those are in degrees. I want radians. So I can take this times pi over 180 to just turn my degree answers into radians. That works. Option 2 would have been at the very beginning of the problem to turn that into a negative pi over 6. Oh, wait, no, I'm thinking 330. All the way around. Yep. 330 is negative pi over 6. Negative 330 is 11 pi over 6. Correct. And then from there, I'll just add 2 pi, which is 12 pi over 6, getting pi over 6. Or I will subtract 2 pi, which is 12 pi over 6, getting negative 23 pi over 6. Huh.
That's not it.
I was kind of going cross-eyed too. I honestly didn't see D.
So in the beginning, if you notice that it's in 30s and not like 45s, could you also cross out the pi over 4?
Yes. Y'all hear that? Or are you busy flapping your lips? If you notice that this is going to have a reference angle that is something with 30-degree increments, you can immediately toss out A and E because those are in 45-degree increments as pi over 4. Yeah, that is exactly correct. That's a nice thing about multiple choice is you can eliminate things like that. Linear speed, angular speed, find the radius. If something is 550 inches to 1 hour, and angular speed is 0.09 revolutions to a minute. In order to compare these, first they got to be in the same unit in time. I don't want to know what you can do in one day versus your friend in one class. Like, it doesn't matter. You compare time to time. So do you want to turn one of them to minutes or the other into hours? Hours? Okay. So there is 60 minutes to 1 hour. Which is, what, 0.54? No, 5.4. Right? Because you move it once, and then by 6. Yeah, 5.4. Revolutions per minute. Per hour. They're both in hours. I now know that 550 inches is equal to 5.4 revolutions. What's the magic boundary I cross to go from linear to angular velocity? 1 radian is 1 radius. Okay, that was a definition. So I need to somehow switch this guy over and say 1 revolution is 2 pi radians. So now we have 550 inches is 10.8 pi radians, but it's also 10.8 pi radii. If I want to know what 1 radius is, it's that many radii, so that many times x, which is the length of my radius. Divide it. If I take 550 divided by 10.8 pi, I will get the length of a radius. And if you type, I bet I did it. Been a long time since I did it, but I bet I did it. 550 divided by 10.8 pi. Oh, I'll be damned, I didn't. What's wrong with this statement? Divided by 10.8, then multiplied by pi. Okay, I have to take 550, divide it by 10.8 pi. That's more like it. Okay. And this will work whether you turn this one into hours or that one into minutes. You're still going to be comparing the same size of things. They're just in a different unit. That'd be like if I asked for your height in centimeters versus your height in inches. It's still your height. The amount of it hasn't changed. So, now that's 20 questions with explanation, and it took us about the 90-minute block, about 80. Naturally, you shouldn't have to roll through a full explanation with every problem. I said most kids will finish this in about an hour per section. Most kids. Some will go up to that 90-minute buzzer and be panicking. What?
Actually, Justin does 20.
It's kind of goes both ways. Because for our class, if you need the notes, then it take longer. But if you don't need the notes,
So,
For our class, we go into lunch after our first test, and then our second test, there's an open block after it. So I mean, kind of have a little bit.
if you wanted to just sit here and keep going, that's fine. So, any what? When I actually grade them. I was going to grade them this weekend, but then people made me not care.
Would you like it if I turned in my Chuck and my stuff now, and then come in here and explain that?
Yes, because I'll be grading all this afternoon. I'll just take it. Okay.